Hi, I'm Phoenix, and I just finished my freshman year of college, and I took AP Calculus my senior year of high school. So before we start the work, one, if you don't know the power, product, quotient, or chain rule, we have separate videos on that you should watch before this, because all of these problems will have those rules in them. And also, if you want to do the work with me, the worksheet and answers are linked in the description below, so you can look at those and work along with the video. So let's get started. So this first question is a quotient rule question, and the rule for quotient rule is low d high minus high d low. So we'll get y prime equals low 1 plus ln of x times the derivative of high, which is negative 1 over x, minus high 1 minus ln of x times the derivative of low, which is 1 over x. And then that goes over low squared, which is 1 plus ln of x squared. Okay, and the next question we'll do is our first product rule question. And keep in mind that each of these things, as I'm underlining here, each of these have functions within themselves. So this problem will also require the chain rule. So for this question, we will get f prime of x equals 2 times x squared plus 1 times 2x times arctan 3x plus x squared plus 1 squared times the derivative of arctan, which is 1 over 1 plus 3x squared times 3. Okay, and so to go in a little more depth on how we found this answer. So first we took the derivative of our first function. So we did the power rule and pulled down the 2 and then got 2x squared plus 1 times 2x. So we had to do the chain rule here with the x squared, and that's how we got the 2x. And then times the original function of arctan plus 3x. And then we add this plus the original of the first function, x squared plus 1 squared, and then times the derivative of arctan 3x. So the derivative of arctan is 1 over 1 plus x squared. And so here we get 1 over 1 plus 3x squared. And then because of the chain rule, we multiply it times 3. And for this question also, you need to make sure you have parentheses around the 3x, because the 3 should also be squared, not just x. So it's really important to keep the parentheses here. Okay, yeah, that's it for this question. Let's keep going. Okay, our next question is a quotient rule question. And there's also the chain rule involved, which is why I circled that 3x to indicate that we do have chain rule in this question. So the answer we get is f prime of x is x squared plus 2, so low d high minus high d low. So this is low times the derivative of high, which is similar to the one we just did. This arctan, it's the same derivative. And then minus high, 5 inverse cotangent of 3x times the derivative of the low over low squared. Yeah, so that's that question. And the derivative of here that we use of inverse of cotangent is the same one of arctan. So that is 1 over 1 plus x squared, which is how we get this derivative. Okay, so before we get started on the next question, it's important to note that This can get confused as the product rule, but this is not the product rule because it is a number times a function, not a function times a function. And this question also involves the chain rule, but we'll get into that. So yeah, so I'm circling this x squared to indicate that this also has the chain rule. And then we'll get the answer f prime of x equals -3 e to the x squared times 2x. And that times 2x is because of the chain rule. And something important to note here is that one issue that people frequently have with the chain rule is that they chain too much. So you might be tempted to add a times 2 to this question. But here's a hint for these kinds of questions is that you should only take the derivative of things that are originally written in the question. So here we take the derivative of the x squared because it's in our original question, as we can see here. So we take the derivative of that as part of the chain rule. But this 2x is not part of the original question. So once we have that, we're done. We don't need to chain anymore. So it's a really handy hint to use when you're using the chain rule and you're not sure when you're supposed to stop. Just go look back at your original question and you can see when you could chain too much. Okay, so moving on to number 5. This is a product rule question. And so we will employ the product rule to solve this. So f prime of x is, okay, so f prime of x, so the derivative of 100 is 0, so you don't have to write anything down for that. And then we use product rule for this function, so we get 4x cubed ln of x plus x to the 4th plus 1 over x. And that's it for that question. It's just a simple product rule question. Okay, so this next derivative, number 6, we're just using the chain rule, and I underlined the tan x to indicate that we need to use chain rule. And so we get f prime of x is equal to -1 over the square root of 1 minus tan x squared, and times secant squared x because of the chain rule. And so here, we get the first part of the question because the derivative of the inverse of cosine is -1 over the square root of 1 minus x squared. So that's how we get this. And then because we have to use chain rule with the tan x, we multiply it times secant squared x, which is the derivative of tangent. And then, so moving on to number 7, this is a quotient rule question. And so we're going to rewrite this. We're going to rewrite the square root of the denominator because it'll help us use the power rule when we're finding the derivative. So then for our answer, let's see if we get there. Yeah, so here we rewrote it, and now this is a quotient rule question. And so the answer we get is, let me fast forward a little bit to get to, okay, yeah. So the answer we get is h prime of x equals, so this is low d high minus high d low. So we get the square root of x squared plus 1 times the derivative of the denominator, or low d high, the derivative of the numerator, sorry, minus high d low. And then we also have to do the chain rule with the 2x, and I circled that here. So that is how we get the answer for that question. Okay, so number 8, this is a product rule question that also requires the chain rule because we have an inside function. And so we get so yes, the product rule question, and we also have chain rule. And then we will get y prime is equal to 1 over the square root of 1 minus t times e to the t squared times e to the t plus t times e to the t. And so the way we get this is first the derivative of the inverse of sine is 1 over the square root of 1 minus x squared. So that's how we get this with our inside function. And then we have to use the chain rule here, and our inside function actually requires the product rule also. And so then we multiply times the derivative of t times e to the t using the product rule and get e to the t plus t times e to the t. So that's how we work that question. So number 9 uses a rule that isn't used that often, which is log base a of x equals 1 over ln of a times x. And so here we have log base 5, and since there's a 2x here, we also have to use the chain rule. So we'll get y prime equals 1 over ln of 5 times x, which in this case is 2x. And then because of the chain rule, we'll multiply this by 2. So that's the end of the first page. And so we're moving on to the next page of derivatives. Okay, so number 10 is a pretty simple product rule question with the chain rule also involved. And so for the answer for this one, we'll get g prime of x equals 1 over x times sine x plus 1 for the first part. And then for chain rule here, as I added a little multiplication sign right there, but that indicates that we have to do the product rule when we're doing chain rule. So as you can see, as I'm doing the chain rule, it also involves the product rule, and we get sine x plus x times cosine of x at the end of the question. For number 11, this is a quotient rule question, and here there's no inside function, excuse me, so we don't have to do chain rule. So we're just doing low d high minus high d low, and we'll get f prime of x equals low 3x squared plus 1 times the derivative of high, negative sine of x, minus high d low, over low squared, which is 3x squared plus 1. Okay. So for number 12, we're going to start by rewriting the question so that it's easier to use the power rule when we're solving the derivative. Okay, so you can see I've rewritten the question here. And then for this question, this is a hard question because we have to take, since there are 3 functions, 3 outside functions, we have to do the chain rule twice. So we have the x cubed, and then we have the secant, and then we have the 2x. So we have to do extra chain rule in this question, which makes it a little difficult. But if you're aware of that, it's not hard. So yeah, so I underlined both of these things to show we have to do the chain rule twice. And then we will get our answer, which is f prime of x is equal to 3 secant squared 2x times secant 2x times tan 2x times 2. And so this is something I mentioned earlier, but this is a question where the chain rule can be a little bit confusing, but here this doesn't change because it's the inside function and we're still haven't finished the chain rule. So we're not done until we have taken the derivative of 2x, and then we don't want to, so that's it. So for number 13, again, we're going to rewrite our function so that it is easier to use the power rule. And so we'll just write the sine squared x and that it's the power as sine x squared, so that it's easier for us to use the power rule later on. And so the rule for the first part of the derivative is the derivative of a to the x. So since it's not x to something, it's 4 to something, we have to use the rule a to the x equals ln of a, which is not the power rule. And so here we'll get so for our answer, we'll get f prime of x is equal to 4 to the sine squared x times ln of 4 times 2 sine x times cosine x. And that's part of the chain rule. And here I'm going to mention the hint we used earlier to make sure you don't chain too much. And so we won't take the derivative of cosine here because that would be too much, because as we can see, cosine is not in the original question. The last function in the original question is sine x, so that's the last thing we will take the derivative of as part of the chain rule. Okay, so moving on to 14. This is a product rule question that also involves the chain rule, and we'll have to do product rule when we're doing the chain rule. And so here we'll get f prime of x equals e to x squared times sine x times 2x sine x plus x squared cosine x. And so the way I explain this might be a little bit confusing, but basically this is we're just doing the chain rule, and then we have to do the product rule as we are doing the chain rule at the end. So the derivative of e to anything is just e to that thing. So when we take the derivative of this question, we just get e to the x squared plus sine x. But then since we have to do chain rule, we have to take the derivative of this, and then doing that, we have to use the product rule, which is how we get our final answer. Hope that makes more sense. And then, so moving on to number 15, this is just a standard quotient rule question. But as with any question, with quotient rule, we need to be careful with our parentheses. So for our answer, we'll get f prime of x equals low 1 minus 2x times d high minus high 2x plus 1 times d low over low squared. So for number 16, this is one we're also going to rewrite to make it easier to find our derivative. So we will write the sine cubed x as sine x cubed instead. And then this question is a product rule and chain rule question. And so I'll indicate that this is chain rule as we have that function sine x in the inside, so we have to do chain rule. And so for our answer, we will get f prime of x equals 3 sine squared x times cosine x plus sine cubed x times the negative sine of x. For number 17, we have a product rule question. So because we have x squared times the inverse of cosecant x squared. And we also have chain rule because we have x squared as our inside function. So this is a product rule question. And we will get y prime equals 2x, so the derivative of the first function, times cosecant, the inverse of cosecant x squared plus x squared times the derivative of the inverse of cosecant, which is, we get -1 over x squared times the square root of x squared minus 1. And the original derivative of the inverse of cosecant, just so that makes a little more sense, is -1 over x times the square root of x squared minus 1. And so since our inside function here is x squared, that stays the same here. And then we will do the chain rule and multiply that times 2x. So then moving on to 18. This question also uses a rule that we don't use that often, that we talked about earlier, which is log base a of x is equal to 1 over ln of a plus x. And it also uses the rule of a to the x equals a to the x times ln of a. So this question uses the chain rule, not the power rule, and we will use both of those rules to get our answer. So we get f prime of x is equal to 1 over ln of 4 times 3 to the x. And then because we're doing chain rule, we get 3 to the x times ln of 3. And that's our final answer for that question. So then for number 19, this is also a product rule question that involves the chain rule. And for one thing to note is that we have a negative x right here. And negative x, since it's such a simple thing, people forget that you have to take the derivative of negative x because it's not just x, it has the negative in front of it. So it does require that you take a derivative of it as part of the function. And then, so we'll do the product rule, and then we will get g prime of x is equal to 6 to the negative x times ln of 6 times negative 1. So this is when we use the chain rule for the negative x, times secant x squared plus 6 to the negative x. Move this up here so you can see. Times secant x squared tan x squared times 2x. And that's how we get our final answer. But the most important thing to look out for in this question is doing the chain rule with this negative x, because it is a very easy thing to miss and trip up on, and people do very often. So look out for that. And then our last question, number 20, this is a quotient rule question. Oh, wait a second. Okay, so as I said, this is a quotient rule question that, just like the last question, we have to do the chain rule with this negative x, and I circled it. So we'll get f prime of x equals ln of x times e to the negative x times negative 1. So here's the chain rule with the negative x, minus e to the negative x times 1 over x over ln of x squared. Just go forward a little bit. Yeah, so here's how we get our final answer. And remember, to get this, we used the quotient rule, which is low times d high minus high d low over low squared. So that is all. And thanks for watching. I hope this was helpful. And remember that we have lots of calculus videos on our channel. So if you found this helpful and if you want to use our other videos, please like and subscribe. Thanks.